Welcome. Today we're going to be talking about Earth and space, mainly focusing on the northern and southern lights. The light we see from ground is caused by electrically charged particles. When charged particles from the sun strike atoms in Earth's atmosphere, they cause electrons in the atoms to move to higher energy orbits, further away from the nucleus. The sun is constantly pushing out a stream of electrically charged particles called the solar wind, and this travels out from the sun at between 300 and 500 kilometers per second in all directions. When the electrons drop back to a lower energy orbit, that's when they release a photon, meaning light. This process creates the beautiful aurora or northern lights. Atoms consist of a central nucleus and a surrounding cloud of electrons encircling the nucleus in an orbit. As the Earth travels around the sun, a small fraction of particles from the solar wind are intercepted by the planet. Around 98% of these particles are deflected by the Earth's magnetic field and continue their journey into deep space. A small percentage of particles leak through the Earth's magnetic field and are funneled downwards towards the Earth's magnetic north and south poles. When these charged particles hit the atoms and the molecules high up in our atmosphere, they become excited. This creates two glowing rings of auroral emission around the north and south magnetic poles known as auroral ovals. The sun's outer atmosphere, the superhot corona, is a source of solar wind, a steady outflow of charged particles from the sun. These particles have gained enough energy to fill the heliosphere, a region of space that extends well past the orbit of Pluto. As these particles flow past Earth's orbit, they're traveling at an average of 400 kilometers per second. The solar wind is primarily composed of roughly equal numbers of protons and electrons, as well as a few heavier ions. Ionic bonding is the complete transfer of valence electrons between atoms. It is a type of chemical bond that generates two oppositely charged ions. In ionic bonds, the metal loses electrons to become a positively charged cation, where the nonmetals accept those electrons to become a negatively charged anion. Ionic bonds require an electron donor, often a metal, and an electron acceptor, a nonmetal, meaning if the solar wind's elements are cations and anions, then it would be an ionic type of bonding. Covalent bonding is the sharing of electrons between atoms. This type of bonding occurs between two atoms of the same element or of elements close to each other in the periodic table. This bonding occurs primarily between nonmetals. However, it can be observed between nonmetals and metals. If the solar wind's elements form a covalent bond, the example shows what it would look like. Some of the differences between them would be ionic is the complete transfer of valence electrons, and covalent is the sharing of electrons. They occur most frequently in a belt with a radius of 2,500 kilometers centered on the magnetic North Pole. This so-called auroral zone extends over northern Scandinavian island, the southern tip of Greenland, and continuing over northern Canada, Alaska, and along the northern coast of Siberia. This is an example of what is happening. Most aurorae occur between 90 and 130 kilometers above sea level, but some, particularly like the ray forms, extend to several hundred kilometers up. In comparison, the usual altitude for a jet aircraft is around 10 kilometers, and the ozone layer lies between 20 and 30 kilometers.
The aurora happen when these high-energy particles bump into atoms and molecules in the Earth's atmosphere, typically oxygen. Light is emitted as part of the reaction. Those particles can also wreak havoc. The plasma cloud can cause the Earth's magnetic field to fluctuate. At worst, that can knock out satellites and even power grids. Aurora can happen at any time, but it's no surprise they're happening now. We are nearing the solar maximum, which is when the sun is at its most active. In northern latitudes, the effect is known as the aurora borealis, or the northern lights. The southern counterpart, the aurora australis, or the southern lights, has features almost identical to the aurora borealis and changes simultaneously with the changes in the northern auroral zone. The northern lights are actually the result of collisions between gaseous particles in the Earth's atmosphere with charged particles released from the sun's atmosphere. Variations in color are due to the types of gas particles that are colliding. The most common auroral color, pale yellowish green, is produced by oxygen molecules located about 60 miles above the Earth. At the extreme temperature of the sun, collisions between gas molecules are frequent and explosive. Free electrons and protons are thrown from the sun's atmosphere and blown towards the Earth by solar wind. Most are deflected by the atmosphere. However, the Earth's magnetic field is weaker at either pole, and therefore some particles enter the Earth's atmosphere and collide with gas particles. These collisions emit light that we perceive as the dancing lights of the north and south. They can send spacecraft to the planets. Man-made robots have landed on the Moon, Venus, and Mars and studied their surface. Spacecraft has also orbited or passed by all of the planets, and there is a spacecraft on its way out to study trans-Neptunian objects. They have also dropped atmospheric probes into the planets like Jupiter that are made of gas. Spacecraft that land on the planets or enter their atmospheres can use scientific instruments to find out what the planet is made of. They can also observe objects from afar and learn a lot about them just by studying the light that they give off or that they reflect. In almost every case, scientists use some variation of an instrument called a spectrometer. Spectrometers take a signal from whatever they're looking at, whether it's a rock, a cloud, a whole planet, a star, a galaxy, or a nebula, and they spread the signal to its components. Most spectrometers work with light and are a lot like prisms. They take the light coming from some object and separate it out into its colors. This is useful because it turns out that every element on the periodic table only gives off light of a few certain colors, so if they spread out the light coming from some object and see only certain colors, then they can match those colors with the elements that produce them. In fact, electricity causes every element in this entire periodic table to glow with a distinct color, like argon blue and helium pink. The particular series of colored lines that you get out of any specific element is called the element's atomic spectrum or emission spectrum. This is the slide of the different spectrums. A comet is an icy small solar system body that, when passing close to the sun, warms and begins to release gases, a process called outgassing. This produces a visible atmosphere or coma, and sometimes also called a tail. These phenomena are due to the effects of the solar radiation and the solar wind acting upon the nucleus of the comet. Comet nuclei range from a few hundred meters to tens of kilometers across that are composed of loose collections of ice, dust, and small rocky particles. Comets usually have highly eccentric elliptical orbits, and they have a wide range of orbital periods, ranging from several years to potentially several millions of years. Short-period comets originate in the Kuiper Belt or associated scattered disk, which lie beyond the orbit of Neptune. Long-period comets are thought to originate in the Oort cloud, a spherical cloud of icy bodies extending from the outside of the Kuiper Belt to halfway to the nearest star. They are composed of organic compounds, rock, dust, ice, and frozen gases. Sometimes called dirty snowballs, recent studies have shown that the ice of a comet is covered by a crust. The kinetic molecular theory of gases describes the state of matter as composed of tiny particles in constant motion with a lot of distance between particles. Because most of the volume occupied by a gas is empty space, a gas has a low density and can expand or contract under the appropriate influence. Kinetic molecular theory states that gas particles are in constant motion and exhibit perfectly elastic conditions. Kinetic molecular theory can also be used to explain both Charles and Boyle's law. The average kinetic energy of a collection of gas particles is directly proportional to the absolute temperature only. Thank you for watching.